Hey everyone, welcome back to the Weekly Coder. This week we are actually going to work on episode 2 of Frogger. Before I start working on this episode, I'd like to make a quick announcement that apart from Patreon, there's one more way that you can actually support the channel. Of course, there are several different kinds of ways you can show your support. You can be a subscriber. You can invite friends and family to the channel to subscribe. And then there's financial support, which is always welcome. And that you can do via Patreon, or you can actually now click the join button on my YouTube channel and become a paid member. So what that'll give you is basically the same kind of thing that you're getting with Patreon at the moment, which is access to the source code files for every week's episode. So what I'm going to do is with the paid memberships on YouTube is every time I release a new video, I'm also going to make a private member-only post that is going to include a link with a download to the source code for you to utilize. So if you want to check that out, head on, well, there's not really anywhere for you to go. All you have to do is you look underneath the video, you'll see a little join button at the bottom. So you just click on that. And, it's $4.99. You can sign up via credit card or PayPal, and you will have access to every video's source documents or source project files. All right? So, enough about that. One more other announcement. If you haven't checked it out yet, check out my new channel. It's called Code Scruffs. It's a channel where my brother and I collaborate to make video games, and we're trying to do it in an entertaining and fun way. So check that out. Link down in the description and down below in the video. And, without any further ado, I will bid you the Frogger episode 2. So here we go. Let's open that bad boy up. What we're going to do in this episode is it's going to be very, very simple. And so this might make a quick episode. So basically, we are going to do the movement of the frog, which we don't have yet. And I see there might be an issue here. Yeah. So these... What is going on here? Nope. That one's right. So we're missing an asset here. So I don't know what happened. I'm pretty sure we had this in here before. And the pixels per unit on this isn't even right. So that's weird. So let me fix that real quick. Pixels per unit is 16. We're going to change this to point no filter. Apply. And then let's move this into position. Wait a minute. It was in there. It was there. It just, I guess, didn't save the pixels per unit. That was strange. Alright, so now if we play, we're good. Okay, that's exactly what we want. All right. So the first thing we're going to do is we are going to import Frogger. And with that, there are 4 assets for Frogger. And they are basically for his different looks for his movement. So he looks different when he moves up versus when he moves down versus when he moves left to right. So there are 4 different sprites that we're going to look at for that movement. So what we'll do is in the graphics folder, we're going to throw in those sprites. So this will be an asset for you to download. So we'll just go here. All right. So here are the 4 Frogger sprites that we're going to use. So let's go ahead and select all of them. And then we're going to go to pixels per unit, and we're going to change that to 16. And we're going to change the filter mode to point and click apply. Alright. So, first things first, we're going to start with Frogger up. And we're just going to drag him into our hierarchy. And he kind of shows up in the middle of the screen, which is fine. But what I want to do is I want to set his order and layer to something like 2, so that he is always going to be above all of these items. And let's see, what else do we want to do? We want to change his initial position to y equals -6. And that kind of puts him here at the starting position, so that when we press play, our Frogger starts exactly in the center in the X position, and he starts at -6 in the Y position, okay? So we're not going to call this Frogger up. We're actually just going to call this Frogger. Or, better yet, let's just call this player, not to be confusing. So we've got player. So now you'll see that player has a sprite renderer, and the sprite renderer has a sprite component. So right now, the sprite that is within that sprite component is Frogger up. If we wanted to use a different sprite, we simply could drag in, like for instance, Frogger right to here, and now it's Frogger right. Now we've got a different image being displayed, which is fine, but we're always going to start out with Frogger up. That's how the game starts. But if you look at that, you can kind of think of how you're going to, in the code, change these up, okay, based on his movement. So you would need to, now let's think this through logically, right? You would need to get the frog, so the player, right? The player game object. And then to get to this sprite property, what we would need to do is we would need to get at this component. So in order to get at that component, there's a method or a class, a method called getComponent. Okay, so then getComponent, and then we say, okay, well, what kind of component do we want to get? We want to get the sprite renderer component, and then we want to access the sprite property of that component and assign a different sprite. Now, how do we call these sprites? The best way is to create a script with 4 public variables of type sprite, which we then will assign these sprites to. Okay, so we're going to take those sprites, we're going to assign those to those public variables, and then we're going to have access to those in our script where we set the sprite depending on which position the player is going. That brings up another question. How are we going to handle that? So we can use the input class to use the methods in that class to detect whether or not a specific key has been pressed, such as the up arrow, the left arrow, the right arrow, or the down arrow. So now that we have kind of an idea of how we're going to construct our script, let's go ahead and open up, or not open up, but actually let's go into, let's create a new folder because we don't have a scripts folder yet. So we're going to go right click on assets and click on create, and then we're going to do a C# script. And that was not the right way to do that. I was going to create a folder actually. But since we've already got this, let's call it player. Alright. Let's go ahead and right-click assets again and click on create. And we're going to this time click on folder. And we're going to name this scripts. And we're just going to drag the player script into that. And then so that we don't forget, let's go ahead and click on our player game object and take our script and drag it into the inspector of that game object. So now that that script's attached, we don't have to worry about attaching it later. So let's open up this script. And I think what I've been wanting to do is Visual Studio looks kind of bland, being all white and stuff like that. So I want to go in and do a dark mode. Let's make it darker than what it is. So not white. Anything but white. Alright, so we go into Visual Studio Community, we go to Preferences, and, well look, User Interface Theme, we have a choice between light and dark. Let's check that out. Let's see what happens here. Alright, it wants to restart Visual Studio. Ooh, looks better already. Nice. Okay. So we'll open up our project. Okay, this is kind of cool. I'm digging this. This is pretty neat. Everything is just so much easier to read. It's the white is just it's so bright on your eyes. It's not good for you. So this is what we're gonna go with, and hopefully you guys will be okay with that. I like it better. So here we go. We've got our start method as usual, our update method. We don't actually need to use either of those at the very moment, but remember how we talked about creating 4 public variables of type sprite so that we can store all those 4 sprites in them? So let's go ahead and do that right now. So we're going to do a public sprite, and let's call it player up. And since they're all going to be of type sprite, we don't have to create 4 separate lines of code, and we don't have to write public sprite 4 times. We can simply add a comma here and then do player down, comma, player left, comma, player right. So this just kind of makes it easier and saves a lot of space. We just basically created these 4 variables on one line of code, and by only telling it public sprite once, right? So if we save this and we go back to Unity, click on our player game object, you can now see that we've got player up, player down, player left, and player right, and it's asking for sprites. So if we go into our graphics folder, and we have our sprites here, let's take Frogger up, put him in the Frogger up position, Frogger right, put him in Frogger right, Frogger left, goes to Frogger left, and Frogger down goes to Frogger down. Player down. Okay, so now we're using 2 different naming schemes. We've got player and Frogger. Doesn't matter, we're all good. Okay, so back to the script. Alright, so now that we've got these, we can reference them because they have the actual graphics on them. So whenever we reference one of these variables, they're referencing the actual graphic, which is cool. So now what we want to do is we're going to, in the update method, we're going to call update position. And because we don't have an update position method, it's going to actually give us like this little red line underneath to tell us, hey, you know what? The name update position does not exist in a current context. Why it can't say, hey, you forgot to create a method, dumbass? That's still like a requested feature of mine. You know, be a little more English about it. So here what we can do is we can actually, there's like a little drop down here if you hover over this, right? So if you hover, then there's a little drop down. You can click on that and it gives you some options. So here we can just generate method player.updatePosition. So if we do that, look at that. We get a whole new method that's already created for us. We didn't even have to create this. So we saved ourselves a little bit of typing here, okay? And it creates it as a private method and a void, so it doesn't return anything, which is cool because we don't need it to return anything, and we also don't need it to be able to be accessible from anywhere else. So this is good. So what's this though? What's this throw new not implemented exception? Well, what that's for is if this is called and there's nothing in it, in the log, what we'll see here is a not implemented exception to let us know that we haven't done anything with this method yet. So I'm going to save this and I'm just going to show you what this looks like. And this is just for like debugging and troubleshooting purposes. So if you look at the console, we're getting these messages over and over again because the update runs every frame and it calls that method every frame. So we're getting this not implemented exception. The method or operation is not implemented. So it's still allowing our code to run. It's just throwing up this error to let us know that, hey, you know what? You put this here, and I don't know why I just did that. You put this here, and we're just letting you know that it's still here and that you haven't done anything with it. So we go into the script, and we basically say, all right, well, you know what? Let's get rid of that, and let's actually do something with this update position. So in the update position, we're just basically going to say if input dot get key, and we're going to do get key down, key code dot up arrow. All right. So basically, what that if statement's telling you is if the get key down method passing in the up arrow key returns true, then we're going to be inside of this if statement. Okay? And we'll do else if input dot get key down. Oops. Key down. Key code dot down arrow. And then again, we'll do another yeah, that's how that goes. We will do another else if input dot get key down, and this time it'll be key code dot left arrow. And you know, just doing these in this order because I want to. You guys can start with the left arrow and end with the up arrow. It doesn't matter. They are all going to get called because it's going to check this at every frame. It's going to check if one of these is true. Even if one of them is true, well, if one of them is true, then it's not going to check the others, and that's why we're doing else if statements. So, and that is the proper way to do it, unless you wanted to check for multiple keys. Let me finish typing this and then I'll explain a little more. What have I done? Oh god. So, there. That's what happens when I try to type and talk at the same time. Okay, so yeah, so else if. The reason that we're doing else if is because let's say that this is false. It gets to this one and says, hey, this one's true. So what's going to happen here is once it finds this one true, it's not going to run these other conditions. So it's optimized, okay? If we had an if statement and another if statement and another if statement and another if statement, then it would check every single one of these if statements, even if it found the first one to be true or the second one to be true. It would still check the other two because the other two are independent of the other one. So this is kind of like this whole thing right here is one conditional block. You're basically testing for one true option. Okay, so once you find your one true, then you're done. You're out of this logic block. So, what do we want to do? Like, if we get the up arrow? Well, I think the one thing that we're going to want to do is we're going to want to change the image, right? So, in this script, that's a component of our game object, which we want to get another component for. All we'd really have to do is say get component, because we're already on the game object. We're going to tell it we want the sprite renderer. And then we want to get at the sprite, and we want to set the sprite equal to player up. Okay? That's basically what we're going to do for all of them. So get component, sprite renderer, dot sprite, player down, and get component, sprite renderer, dot sprite, player left, and get component, sprite renderer, oops, dot sprite, player right. Okay, so with this code, let's save. We should be able to press play, and we should be able to use our arrow keys to basically try to move. We won't be able to move because we haven't done any code there yet, but our image should change. So I'm going to press up, and of course that's not going to do anything. If I press left, we get the left image. If I press right, he turns around to the other side. Right, left, yeah. If I press down, he goes down and up, down and up and down and up. Alright, so our images are changing exactly the way we want them to change. Now, let's go back into our script and let's do some more magic here. We're going to actually make it move now. So, with this game, we want Frogger to move 1 unit for every key press. So what that means is, since we've set everything to be pixels per unit for 16, and all the sprites are basically 16 pixels, what we're left with is if we move 1 unit, we just move 1 unit. We move 16 pixels is our 1 unit move. Okay, so we don't have to do any complicated math of trying to add up the pixels or anything. We just tell it to move 1 in whatever direction that we want to move in. So if we want to move up, for instance, which is also consequently, it's also forward. So we could have called that forward and backward, but I think up and down is a little more understandable because he actually moves up and down on the screen. It's a 2D game. So we have player up. What we want to do is, first, we can't modify the position or the X position or Y position properties independently on the directly on the local position. So we have to create a vector2 that is a position variable that will be updated. And then at the very end of all of it, we're going to set we're going to set our transform's local position equal to the position variable. So unassigned. Okay, that's because there's nothing assigned to it yet. So once we assign something, so like position dot y, because we're moving up, equals, or let's do plus equals, vector2 dot up. Actually, we don't even have to do position dot y, we just do position. There. It is unassigned. All right. Equals new vector. Actually, what we'll do is equals vector2 dot 0. Or actually, you know what? What we need to do is we need to actually get the position of the transform. So we do transform dot local position because for every time we update the position, we have to know what the previous position is. So let's say that we want to move, or the update position runs. This gets called every frame, right? So at the frame that we're at, let's just call it frame 1, we say what's the current position. So we store that in position. And then we check to see if any of these are true. We move these, right? So let's say that the player pressed up. So we update the position. We then store the position in the local position. And then this gets called again, frame 2. And at that point, we say, oh, okay, well, the position has changed, right? Because it's getting the new position, which has been set here by this position that's been modified. And then it gets set to this position again. And then this position gets incremented to based on what the next move is going to be. All right. And this vector2.up, these are just properties. These are actual vectors that have been created for us. So up would be like saying x equals 0 and y equals 1. And the same thing here with what we're going to do is down. And it's basically going to be x equals 0, y equals -1. And that's basically just movement vectors that we can use that have been created for us. So position plus equals vector2 dot down. And here position plus equals vector2 dot left. And position plus equals vector2 dot right. And now, just so there's no confusion, I want you to know that position plus equals vector2 dot right is basically the same as saying plus equals new vector2 1 0. Basically moving 1 in the x direction and 0 in the y direction. So this is just a simpler way of writing that. So So now our frog should be able to move and change his image. So let's go ahead and click play here. Alright, so we got Frogger, and we press up, 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 and he's moving one unit at a time. So we've got right, but as you'll see, we have no constraints. Our frog can go wherever he pleases, which is not good because that's not what we want. We don't want him to go wherever he wants. That's not the goal here, right? But I think what I'll do is I'll save that for another episode because this one's kind of getting long. So we'll keep it at that, and we'll just title this episode Frogger Movement. Okay, and the next episode we're going to throw in some boundaries and maybe something else. I don't know yet, but we'll throw in something else for sure. Maybe we'll throw in some type of collision detection that will detect and let us know whether or not he's on the water. That'd be kind of cool. Alright, so I want to thank you guys for watching, and I want to thank everyone for supporting the channel. All of you guys who have supported me on Patreon are awesome. I appreciate it very, very much. And all of the future subscribers and supporters, thank you guys so very much. As soon as I get some more supporters, I'm going to start listing all of you guys in the credits to show support. If you want to support through YouTube, you can press the join button. Don't forget to subscribe. Give me a thumbs up if you like the video. Don't forget to click the bell for notifications. I think I've said everything I needed to say, except for don't forget to check out the other channel that I have, Code Scruffs. Awesome. Link is down in the description. Don't forget to download the assets to go along with the tutorial if you're a paid member or if you're a Patreon supporter. I'll have a link to the downloadable project file for you. So until next time.